Welcome back, dear participants, to the last session of our 3 days online faculty development program on sustainable building materials and practices sponsored by APJ Abdul Kalam Technological University. At the end of the session, valedictory function will be there. Participants may please stay back after the session for the function. The winner of our quiz competition will be announced during the function and will be awarded with a cash prize of ₹1,000. For our last session, we have got another distinguished speaker, Dr. Elson John. Dr. Elson John, who is working as Associate Professor in Civil Engineering Department at Mar Athanasius College of Engineering, Kothamangalam since 2000. He completed his MTech in Structural Engineering from VIT Belgaum. He has obtained his PhD degree from IIT Madras in the area of concrete technology. He worked as a research scholar in IIT Madras during 2008 to 2011. He has an industrial experience of 3 years. He has published 24 articles in many journals and conference proceedings at national and international levels and guided around 39 BTech MTech projects. He has also attended and coordinated many conferences, workshops, and short-term courses at state and national levels. Many consultancies and sponsored research works of Panchayat, municipalities, PWD, BSNL, etc. was undertaken by him. He has delivered many keynote lectures at various levels. Presently, he is heading the research center and lab in charge of concrete research lab at MA College of Engineering. With this brief introduction, I would like to invite Dr. Elson John to deliver his talk on the topic more sustainable concrete technology through the effective use of admixtures. Sir, please.
Am I audible?
Yes, sir, you are audible.
Yeah, can you see my screen?
Yes.
Okay, thank you, Babila, for your kind words. So, respected head of the department, Manju George, all other dignitaries present over here, and dear participants. So, let me first thank MBITS College, Kothamangalam, for giving me an opportunity to interact with you. So, always I was in contact with the MBITS for many of such programs, and I do appreciate the Civil Engineering Department of MBITS for coming up lots of programs and innovative ideas to develop the knowledge or the development of the civil area. So I personally congratulate the Civil Engineering Department and the head of the department for the same. I know it's only not because of HOD alone we can do something. There's a team behind this. So I congratulate all the faculty and Department of Civil Engineering for that. So last 3 days, you are talking about sustainable development, right? So whenever we are talking about civil engineering, now everyone is talking about sustainability. So what is sustainability? That already you are very well aware of it. So I'm not going to much of it. So during these interactions, you might have known about the sustainability has 3 sides or 3 components. So let us see how this Congate affects these 3 components. So first one, so in between, because it's a big challenge for me to make you awake till 3:15 p.m. today after the lunch. So in between, I can see your names, and some of the names are very familiar to me. So I will ask you some of the questions. So if you are not responding to these questions, I will call your names because some of the names are very familiar to me. So with this, let us see the 3 aspects of sustainability. One is environmental, then the social, and the economical part of it. So how each of these part will affect, or the concrete will affect these components, and how can we make our structures more sustainable with the effective use of admixtures. So that's what we are going to talk. I think some of you are heard my topics earlier. So this is the almost the same topic, but I'm giving or emphasizing on the sustainability, or how the admixtures can make the concrete more sustainable. That will be the focus on this topic. So let us compare each of these components of sustainability. What is the influence of concrete on that? So first one is the environmental impact. What is the environmental impact of concrete? So concrete has the lowest embodied energy among all construction materials. So what do you mean by embodied energy? It is the total energy consumed for a building structure. So total energy means that's not only for the construction, but from the all the activities directly or indirectly involved or participate for a construction. That starts from the mining of the raw material, processing of the raw materials, mixing of the concrete, transporting, placing, vibrating, finishing, curing. Then it comes till the demolition and disposal. So for a structure, we have to look into the total energy associated with the structure. So that embodied energy, concrete has the lowest value. And the raw materials are available for significant volumes of concrete to be produced. We need huge quantities of raw materials, and those raw materials are mining or getting from the local areas. So we need a huge quantity, and we are aware about in Kerala itself, we have lots of issues with the mining of the materials or the aggregates or the rocks because of lots of environmental issues. So both the above indicate that any improvement will have significant impact. So that means if you want to reduce the consumption or to make your concrete more environmental friendly, we have to reduce the consumption of this raw material so that the total embodied energy will be less. The consumption of the raw material can be reduced. So how these admixtures can help in getting this? That's the discussion today. Then what is the negative impact of concrete on environment? As all of you know, cement production will lead to a lot of environmental issues. Cement production in the world is around 3 billion tons. And the cement manufacturing accounts for about 5% of CO2 emissions in the world. Almost 1 kg of cement will produce 800 to 900, 0.8 to 0.9 kg of carbon dioxide. So that much carbon dioxide is produced. So if you can reduce the consumption of cement, not only we can save the raw materials, but directly we can reduce the emission of carbon dioxide to the atmosphere. So that can lead to environmental issues. How that can be possible? Let us discuss. Then concrete usage estimates vary from 10 to 30 billion tons per year. Now let us come to the economic part. What is the positive impact of concrete on the economy? Construction provides livelihood to a large percentage of population. Almost all our houses are made of above concrete, or wherever you are we are thinking about an infrastructure, we need concrete. So that is a positive impact. It gives the livelihood to large percentage of population. Then the growth of construction cost is also reasonable. Only to 3 to 4% of construction spending is increasing per year. Now, what is the negative impact of concrete? Poor construction with concrete can lead to high repair and rehabilitation costs. That we are seeing always in our structures. Almost all the structures we are facing the difficulties or problems with it. We are designing a bridge for 115 years or claiming that it will be sustained for 100 years. And we have our example in our neighborhood itself. The bridge is demolished after 2.5 years of life cycle, or 2.5 years. Why it is? There are lots of factors behind it. I'm not going to give an example or details about it. It may be the design, it may be the materials, it may be the methodology we followed for construction or construction techniques, but the poor construction that lead to a lot of repairs. If we are taking the concrete structures, within few years itself, we are seeing a lot of cracking, spalling, all these things. Concrete is a durable material, no doubt on that. But we are making the concrete less durable and make our structure corrode and spall and fail. So that is a negative impact. In leading countries, they are spending 3 to 5% of their GDP for the repair itself. That much huge amount is spending for that. That is a negative impact. And why it is? Many times we will look into cost cutting. That means many times sustainability, green concept, everything we will keep aside. We will look only for economy. So that cost cutting often results in bad quality. So that can lead to problems in the structures. So that is the negative impact. Now, coming to social impact, the positive side, concrete is a long-term investment that is within the reach for most. We are making the structures. We have ancient structures which is withstanding for 100 or 200 years without any damage. And still, we can design a structure with a black and white guarantee that it will last long for 100 years. We can give guarantee. There is design procedure for that. Life cycle prediction of structures. And we can say that if the concrete is having this much quality, the building will sustain for 100 years. Normally, the buildings we are designing for 50 or 60 years. And how the durability is ensured in our structure? Our IS code is giving some points for that. One is minimum cement content to be used, maximum cement content to be used, maximum water ratio to be followed, minimum grade of concrete to be used for various exposure conditions, and the clear cover. These are the things which is mentioned in the IS 456 for making the structure durable. But is it sufficient? If you follow this, it is sufficient good. But if you are going for 100 years of life span for a structure, is it sufficient? It is not. Even though we are not even following, we are specifying for a beam, the clear cover is specified as 25 mm. Why it is specified as 25 mm? As we civil engineers, are we bothered about it anywhere in any structures? We are designing or we are teaching, that's all. In the structure, is it ensured? Many times after the construction, after the removal of formwork, if you go to the site, you can check the reinforcement after that. Because there will be lots of honeycombs. Some areas there won't be any concrete at all, especially if the reinforcement is congested or the area of reinforcement is more or the number of bars are more. Why this 25 mm is specified? Because if we are using a good quality concrete without any honeycombs or any defects, it is exposed to atmosphere. So all the durability issues will start on the surface of the concrete. Say oxygen impregnation, moisture impregnation, sulfate attack, chloride attack, carbonation, all these durability parameter or detrimental things will attack the concrete. So if you are providing the structure, if you are providing a clear cover of 25 mm, what happens? These ingredients will take time to penetrate through the concrete and reach the reinforcement, and the reinforcement corrodes. So if you are designing for normal structure for 50 years, if you provide a clear cover of 25 mm, it will take 50 years to reach the moisture, oxygen, chloride, to reach the reinforcement, and the reinforcement corrode and it loses its required strength. So that process will take 25 or 50 years. So we are ensuring. But instead of 25, if you are giving 12.5 mm clear cover, the life will not be 25 years. It may be 5 years, 3 years, or 2 years, because it is not on a constant way this percolation will take. It is easy to percolate from the surface because the concentration is too high in the chloride. If it's a marine atmosphere, the chloride concentration on the surface is very high. So it is easy to percolate from the outside. As it goes inside, it is difficult to percolate or penetrate. So the rate will decrease with the time. So if you are reducing from 25 to 12.5 mm, it will reach within 5 years. So we can't expect 25 years of lifetime. That is what we are seeing in our most of the structures. So if you are going, instead of, if I'm saying that, instead of 25, I will give you 50 mm or 75 mm. Is it advisable? The problem is that there will be no confinement for that outside concrete or cover crate concrete. So we have to optimize. And how we can ensure 100 years of lifetime? Because we are specifying in that case, because instead of this normal quality control, we are going for the performance-based specifications. Now the quality of concrete is assessed by the cube strength at site. Is there any relation between these two? Because when you are making the concrete, we are taking the good quality concrete, we are filling the mold properly, we are compacting it properly, keep it at a shade, then cure it properly for 28 days and testing. What happened to the concrete on the site? You can imagine how it is placed, how it is compacted, how it is cured. So there is no relation between. And if that cube strength is getting 25 Newton per mm square, we are saying that the concrete or the structure is safe, where we don't know. So that scenario has to change. Instead of that, you give the freedom to the constructor, whatever they can use it. Take a core from the actual structure, test it for strength as well as durability parameters. So there you need to specify the durability parameters, say water permeability or chloride threshold, like that, or softivity. These are simple tests we can do at any lab. So we can specify that. So if you want your structure to withstand for 100 years, you want to specify this durability parameters, this water permeation or chloride threshold. If it is less than this value, it will take 100 years to reach the reinforcement and reinforcement fail. So we can ensure that. So if you are ensuring the service life of the structure, we can say that it is sustainable. Because otherwise, after 50 years, we need to demolish the structure. For demolition, we need energy. Then we need to move the debris from one place to other. We need transportation. We need dumping. That leads problem to the environment. And again, for the new construction, we need raw material. We need cement, carbon dioxide emission, all these things are happening. So if you can extend your life of your structure, you can say that it is sustainable. So there are, after reconstruction, I feel very funny by reading a article in the paper. So when the decision came to demolish the Palarivatam bridge, there was an article, and I don't want to name who was claiming that after the reconstruction, this bridge will withstand for 100 years. What is the guarantee for that? Anybody can give that in black and white, whether the design or the contractor or the government or anybody responsible. They are demolishing only the superstructure, the foundation, pile cap, everything is same. And they are constructing it without any guarantee. They are telling that. But there are structures in the world which they give black and white guarantee that it will withstand for 100 years. Lots of examples, Confederation Bridge and all those things. Because in that, before design itself, they are specifying the quality of concrete. So the durability parameters should be within this limit. If it is within that limit, it will take 100 years for the detrimental component to percolate through the concrete, reach the reinforcement and fail the structure. Whatever be the reason, the failure of the structure will be due to corrosion and failure of the structure. When the reinforcement corrode, its cross-sectional area decreases. When the cross-sectional area decreases, it exceeds the permissible limit for stress because the entire stress is transferred to a smaller area or the load is transferred to a smaller area. So the stress increases. So what we are talking about, concrete is a long-time investment that is within the cost for most, and it is one of the cheapest material. What's the cost of 1 kg of concrete? Can anybody tell? Cost of 1 kg of concrete. Anybody of you? Manju, am I audible, right?
Yes, sir.
Yeah. Anybody? Nobody is responding.
Yes, sir. What do you want, sir?
Yeah, good morning. What is the cost of 1 kg of concrete?
Kg of concrete mean for mixing of concrete and mixing of concrete, sir. So cement.
Concrete I am asking because we are cost when we are talking, we are telling us it is costly, but everything we are looking into kg.
Yes, sir. But your question
Cost
is
of 1 kg of concrete.
but your question is understand, sir. But 1 kg of cost of concrete, but I don't know, sir. How to heat up the concrete? I know that density and also in the 25 km per meter and everything, sir. But I don't know, sir. If you
talking to students also,
usually I know that. If you, I don't know that, but inform to your answer, sir.
Yeah. So
anybody other than faculty members, so if you ask me that question.
So no, that way. When we are talking giving to the students, they can how to give them.
Yes, sir. Yes, sir.
We are talking
yes, sir. Yes, sir. What do you want? If you want things, sir. Why if you asking that 1 kg of cost, sir?
Because I am asking, because I am telling that it is reaching the within the reach of most, and it is cheap one. So what is that cheapness, or how much it is cheap? That's why we are talking about one. But can I compare that with our concrete steel price? Still, we are talking about 1 kg. Or
Yes, sir.
whatever it may be. So 1 kg of concrete will cost you around 2 to 3 rupees. That's all.
Okay.
1 cube of concrete costs you 500.
In normal concrete, yes, sir.
Please.
In normal concrete, sir.
In
normal
concrete,
conventional concrete. Yes.
If you are talking about M20 or 25 grade of concrete, it's only 2 to 3 rupees. Production.
2 to 3 rupees. Production.
Because but what we are talking that 1 m cube of concrete costs you 5,000 to 6,000 rupees.
Oh, okay.
The density of 1 m cube of concrete, it is 2,400 to 2,500 kg per m cube.
Kg per m cube. Oh, yes.
So when you are talking about 1 kg is 2 to 3 rupees, you will get a comparison with other materials. What is the cost? Otherwise, only we are talking about m cube. All the other materials we are talking in kgs. So that's what I told you, within the reach of cost.
Yes.
It's
Yes,
an
sir.
investment. And
Okay.
positive impact is it can provide security to the user.
Yes.
It's a thing. If you are living inside a concrete structure, you feel that I'm secured.
Good. Yes, sir.
A metal sheet or tile or something like that, some insecurity feeling will be there.
But one thing I ask in the question,
Yeah.
we construct the composite structure for bottom of sheet will be
Which one?
carrying composite structure will be constructed.
Yeah.
Now only if you introduce the composite structure, sir, we one in our college oriented we will be constructing. But
Yeah.
if you bottom of sheet, not only for cup holding work.
Yeah. We can use. There are lots of technologies are available. This. So that depends upon the technology which you are using. I'm talking only about. Okay.
Okay. Okay. Continue, sir. Okay, thank you.
So can provide a security to the users. Then what is the negative impact of social component? Cities are becoming concrete jungles that you can see in our almost all modern cities. So again, the temperature as the concrete during the sunny day, the concrete will absorb the heat and it will release it. So the temperature also it is little bit increase. Then again, quality of concrete is not assured for the user. The quality of concrete is not assured for the user. So that led to lots of issues in the concrete. So a sustainability success requires maximum positive economic, environmental, and social impact. So all these positive impact should be the maximum. So the simple principle for concrete construction for sustainability is use less raw materials and energy over the all life. So can anybody say that? How can you reduce the raw material for concrete by using an admixture? Anybody, if you can suggest? Okay, we don't want to spend time, I will tell. So, for example, we are designing a column. We are making the column with a M20 grade of concrete. So we are getting a cross-sectional area. In the same time, if we are designing the same concrete with a M60 grade of concrete or M50 grade of concrete, what we can do? We will arrive at a lower cross-sectional area. I'm telling you, there should be some minimum dimensions for the syrup on all those. But when it comes to multi-story buildings, if you are going for a high grade of concrete, if you want to make a high grade concrete, we need low water cement ratio and filler or supplementary cementitious material. So those are the admixtures. So we are designing the same structure, same column with the M60 grade of concrete. We can reduce the area by 1/3. So we need only 1/3 of concrete. So that can have a saving in the raw materials, energy to mine it, energy to process it, energy to transport it, energy to mix it, place it, all the things. We can go for a reduced cross-sectional area with the help of admixtures. Then reduce the emissions. When you are reducing the quantity of the material, we can reduce the emissions, carbon dioxide emission, because we need only 1/3 cement required for that. Then analyze cost effectiveness. When you calculate the quantity, when you are going for a high strength concrete, that will be cost effective. Because what we need extra to make a high strength concrete is not that much high. So that can have a cost effectiveness. Again, the transportation, the mixing, placing, all this can be saved. So when you compare, but the normal, what is our problem is that we will just compare the cost of normal concrete or M20 grade concrete and M60 concrete. M60 concrete may be costlier 30% more than M20 grade of concrete, but you need only half quantity. So which is economical. And actually, all we civil engineers are doing a crime when you are talking about sustainability, because we have good quality aggregates. Our granite aggregates are very good in quality. It can take to 70 to 80 tons of load, or 82 tons Newton per mm square, where we are using the latest best quality cement with 53 grade. With that, we can make M200 or 300 grade of concrete, ultra high performance concrete. With this material, we are making a concrete of M20 or M25. So we are actually not utilizing the material properties which we are using. The aggregates can take up to 80 Newton per mm square, but we are using only for 20 Newton per mm square. So we are doing a crime of unnecessarily wasting the natural resources. When you are talking about sustainability, we have to keep these resources for future generation. If you want to make a rock, or if a rock need to form, it will take millions of years. And that material, we are just mine it and we are not utilizing it properly. So that should be avoided. We should go for high strength concrete or high performance concrete that we need admixtures. So reduce the emissions and waste over the whole life. Again, when you are going for a bigger cross section, after the useful life of the structure, we want to demolish it and we want to dump the waste somewhere. So again, that need more energy, space, and problems. When we are talking about, it should be over the all life of the structure when you talk about sustainability, not the initial cost. Then analyze cost effectiveness, then analyze the social impact factor as we discussed earlier. Use less clinker and water and more waste material. I told you how we can reduce the clinker. Go for high strength concrete. And for normal concrete, M20 concrete, our practice in Kerala is to use around 360 to 400 kg per m3, where you can use 200 or 220 kg of cement and 80 or 90 kg of fly ash to get M20 grade of concrete. So what is the advantage? The raw material for cement manufacturing can be saved. The energy required to produce the cement can be saved. Transportation, everything can be reduced. And in the same time, we can use effectively a mineral admixture or a industrial waste material to make the concrete. So we can reduce the consumption of raw material, we can reduce the carbon dioxide emission, and we can use a waste material. Otherwise, that will go for the landfilling. That can lead to dust, environmental, and the hard metals can leach to the groundwater and contaminate. So environmental, air, land, and water pollution can be avoided. Then increase the useful life of the project. That's what I told you. Instead of 50 years, you have to make a structure which will withstand for 150 or 200 years. Then overall cost effectiveness, of course, that we have to consider. Then improve the defect insensitivity. Our structure should be intact and without any defects. So admixtures in concrete, so the time is flying, so I will just give you only the important points of that. So admixtures in concrete. So what's an admixture and why we need it? So what we need is to get the sustainability in concrete, we need high quality concrete. High quality is not only high strength, but it's high performance also. We can achieve this by using alternative or unconventional materials because the industrial requirements are changing nowadays. Earlier, we were talking about 50 or 60 mm slump because concreting, placing, compacting, finishing, everything was manual. Now we are talking about ready-mix concrete. Your concrete is a local call away, so you need to transport. But with the present transportation or traffic conditions, you don't know when your concrete will reach at your site. Sometimes it may take 3 to 4 hours. So your concrete should be workable till that time without the initial set. So workability retention or slump retention, or sometimes we need high strength concrete. Last year, one guy from a prefab unit came to me, and his demand is he was to get 20 Newton per mm square in 12 to 18 hours. I told you it's very easy. We can get it within 4 to 6 hours if you are going for high quality accelerated curing techniques. But he told that I don't want to go for boiler and all those things. I want to do with admixtures. Can we do? Yes, we can. So when this type of unconventional things are happening, requirements are coming, or you need your concrete. Earlier, everybody was talking about M20 to 25 grade of concrete. Now the industry is talking about 60 to 80 Newton per mm square, and many places it is using. In Cochin also, in a project now we are working. That project was actually designed with the M30 grade of concrete. So we are working, redesign and working that with the M50 grade of concrete. How much savings we can achieve with that? Not only the savings, it will ensure the quality or it will enhance the durability of the structure to a big extent. So that's what we are trying to calculate, and we are calculating the service life for that structure with both grades of concrete. We can make sure that for high quality concrete, high grade concrete, high performance concrete, we can enhance the service life of the structure. And that can be achieved with the help of admixtures. What's an admixture? According to ACI, the term admixture is a material other than water, aggregates, hydraulic cement, and fiber reinforcement used as an ingredient of concrete or mortar and added to batch immediately before or during its mixing. Immediately before or during its mixing. No admixture should be added to the concrete once the concrete is prepared. It should be added immediately before or during its mixing. Why to use an admixture in concrete? To satisfy the growing demands of the society and the construction sector, to provide better stability under certain environmental conditions. So for that, you want to go for underwater concreting. So you want your concrete to be more cohesive. You don't want the surrounding water to mix your concrete. So you can go for a viscosity modifying admixture so that your cohesiveness of the concrete will be better and the surrounding water will not mix with the concrete. So like that, lots of admixtures are there. To increase the productivity or efficiency during fabrication, transporting, and placing. The capacity of the traditional materials to satisfy these demands is limited. So admixtures can broadly divided into two. One is chemical admixture and the other one is mineral admixture. So I'm not going detailed about it because I want to wind it up within 15 minutes. So as per the restricted time, I am just rushing. So chemical admixtures, all of you know that what is a chemical admixture? Chemical admixtures are chemicals which are added to the concrete to improve some of the properties to the concrete. And normally the dosage is less than 5% or maybe 2%. So always I used to tell that the process of making concrete is just like cooking. We are making a dish, say veg kurma. You are cooking that at home, your mother is cooking, you are getting it from your canteen, you are getting it from different hotel. But each of these will taste different. What makes the difference? The relative proportion of these materials. The relative proportion of the material. Just like you are getting the raw materials of the concrete from the same source, same quarry you are getting the aggregate, same brand of cement you are using from same batch, same source you are taking the water. And if you are mixing from the same raw material, different manufacturers or designers can make the concrete in different way with a different quality as our dishes taste different. So first importance is the relative proportions. And sometimes in our dish, if you want to add some taste, what we do, we are using some spices. So admixtures in Congate is just like adding spices to improve some of the properties of the Congate. So when I'm talking about super plasticizer, it is just like adding salt to your dish. Without super plasticizer, you can't think about a quality Congate nowadays. You can't think about a quality Congate. It is just like adding salt to your dish. But one thing you should be very careful. If you are adding excess salt, what happens? You can't use your dish at all. You can't eat it. Same like overdosing of admixtures can lead to segregation and bleeding in Congate. That is dangerous. If you are adding less salt to your dish, it won't taste good. Just like if your admixture is not of sufficient dosage, it will not work as we expect. So when you are using the admixtures, one thing you should be very careful, because these admixtures are used for some purpose. Maybe it is to improve the workability. Super plasticizer added to improve the workability. Sometimes these admixtures have some secondary effects. So most of this super plasticizer will have a tendency to decrease the setting time. So that we should be aware about. How this admixture will influence the required property and how it can interfere with the other properties. That's all. So factors that affect the action of the chemical admixtures are dosage and addition process, characteristics of the cement and aggregate, environmental conditions. So the ambient temperature can influence the performance of the admixtures. So chemical admixtures, we can broadly classify it into many groups. One is admixtures that mainly affect the fresh stage, water reducers and super plasticizers. I will talk about 2 minutes later about that because that's the most important thing. Then admixtures that mainly affect the setting stage. You can control your setting time of Congate. Sometimes you want to Congate underwater. So what you need is you want your Congate to set fast. Or you want to make your Congate in a cold climate. So temperature is an accelerator of hydration reaction. So low temperature will decrease it. At lower temperature, Congate will not set for a long time. So that time you need to accelerate the setting. We can go for set accelerators. Or you are going for a prefabrication. You need your formwork to be removed early. You can't take your formwork for 28 days for the next specimens to come. So we can go for set accelerators. Set retarders, you want to transport your Congate for a long time. You can use this admixture so that you can make your Congate workable for a long time. If the ambient temperature is too high, Congate will set fast. You will not get sufficient time for the Congate to place and finish. We can go for a set retarder so that the setting time of the Congate will be delayed. You will get sufficient time for Congate to place and finish. Admixtures that mainly affect the hardening stage. I told you, we need a compressive strength of 20 MPa in 12 hours or 18 hours. We can go for hardening accelerators. Accelerators will only decrease the setting time. It will not increase the strength. But when you are going for a hardener, it will increase the initial strength. Then admixtures that mainly affect the hardened stage, air entraining agents. It will entrain some airs inside the Congate so that it will have better freeze-thaw resistance. I'm not going to details of that. in India or Kerala, we are using this air entraining agent to make lightweight concrete. What we are talking about, the AAC blocks and all are air entrained concrete. There are multi-purpose admixtures, shrinkage reducing admixture. So all of you know that concrete will have a unique property of shrinkage. If you are protected it from the atmosphere also, it will shrink because of the chemical shrinkage. In hydration reaction, the volume of reactants is more than the volume of the product. So that can lead to shrinkage. So shrinkage is happening because of the removal of the water from the pores. So this admixture will reduce the surface tension of the water so that removal of the water will be easy and it will reduce shrinks. Like that, we can alkali aggregate expansion reducing admixtures. We don't have such problems in India, but in some of the countries, they are having big issue with that. Then corrosion inhibitors. If you're adding these admixtures, it will make a layer, a passivative layer on the surface of the reinforcement bars so that the entry of oxygen and moisture to the reacting sites will be prevented and the reinforcement will be protected against corrosion. That is one way of action. The second type of admixtures, they will prevent the entry of moisture into the concrete so that the reinforcement will not corrode. Then surface viscosity modifying agents, I already discussed. Surface retardants. If you want to get a exposed aggregate finish, you just apply these surface retardants on the former, do the concrete, keep it for sufficient days. Only the surface mortar will not set. After removing the former, clean the surface with a jet of water, you will get a modified aggregate surface. Damp proofers or water repellent, micro or nano materials will be added. The purpose is to make the surface of the concrete is just like a lotus leaf, so that the durability issues can be reduced. Then multifunctional admixtures, one admixtures will give more than one purpose. So superplasticizers, why superplasticizers are added to concrete? So there are different ways to approach it. One, you have a concrete, say your concrete is having 50 mm slump. You want to increase this slump. So you can add a superplasticizer so that you can make this slump to 100 or 150 or 200 mm. So to increase the workability. But if I have a concrete, 100 mm slump is there, I am satisfied with that. So if I am adding a admixture, superplasticizer, what will happen normally? The slump will increase, but I want only 100 mm slump. So for the same slump, I can reduce the water content or water cement ratio so that the workability will be the same. So for same water content, we can increase the workability. Now for same workability, we can reduce the water cement ratio. So when the water cement ratio is reducing, what happens? We know Abraham's law. Strength is inversely proportional to water cement ratio. When the water cement ratio is reducing, the strength will be increasing. So when you are reducing, the strength will increase. So for the same cost, we will get a high strength concrete or a little additional cost of admixtures. Now, we are designing the structure for M30 grade of concrete. When you are reducing the water cement ratio, the strength will go to M50. Do actually we need it? No, because we designed it for M50. So for same workability and strength, we can reduce the cement content. For the same workability and strength, we can reduce the cement content. When you are reducing the cement content, what is the advantage? The cost will be reduced, lead to sustainability. The production cement requirement is reducing so that carbon dioxide emission is reducing. Again, sustainability. Again, the raw material required for the cement is reducing. Again, sustainability. So we can make the concrete more sustainable. So mechanism of action, I am not talking much. So again, consequences of superplasticizer usage: reduces placing and compaction time, leading to lower construction cost. Construction cost can be reduced. Facilitates and casting of elements with complex shapes and dense reinforcement. Otherwise, the reinforcement will not have sufficient workability. For example, self-compacting concrete, it will fill the complex shapes. Otherwise, there will be lots of honeycombs that can affect the durability, failure of the structure, and that can lead to less sustainability. Improve surface finish. Superior strength and durability. How superior strength is achieved? Because of the lower water cement ratio. How durability will be improved? That will explain by this figure. So compare to, this is a schematic diagram. Compare two mixers, one with a water cement ratio of 0.65 and the other mix is with a water cement ratio of 0.25. The left side figure, the white portion is water and the gray portion is unhydrated cement paste. When the water cement ratio is high, more water will be there. And you can see that the cement particles are dispersed apart. So what happened? Some part of that cement will be taken for hydration. The remaining water will remain as water itself in the pores. When it is exposed to the atmosphere, what happens? This water will be evaporated. This water will be evaporated, leaving pores inside the concrete. All the detrimental components, chloride, moisture, oxygen, everything will percolate through that porous structure, reach the reinforcement and corrosion will take place. Or the cement matrix will be deteriorated because of the sulfate attack and all these issues. But when the water cement ratio is less, what happens? There is only less water available and that water will be taken for hydration and that pores will be filled with that. And if it evaporates also, you can see in the right side picture, there are cement particles are so close so that the continuity of the pores will not be there. There can be pores, but the interconnectivity of the pores are restricted. So it is not the volume of pores, it is the interconnectivity of the pores that determines the permeability of the concrete. And this permeability will affect the durability of concrete. So when that permeability is reduced, the durability of the structure is increased. When the durability is more, the structure will become more sustainable. So these parts I am skipping. How the superplasticizer can help to make the structure sustainability. More uniform and homogeneous mix, you will get a better performance in terms of workability, strength, durability, constructability, everything. Improved durability aids the use of waste material as mineral admixture or supplementary cementitious material. Then increase tolerance of non-ideal aggregates, improves working condition at the construction site. For example, if you are using self-compacting concrete, you need not vibrate the concrete at all. So that improves the working condition to a great extent because there is no vibration. When you are vibrating the concrete, we are vibrating all the laborers or workers standing on the formwork also. That can affect their health. The person who is operating the vibrating machine can affect the vibration. Then it will produce noise that can affect the health of the workers. So with this is only an example. There are many other examples. Because of the lack of time, I'm just going fast. So compatibility. So I just want to talk 2 minutes about mineral admixture. Why we are? Normally there is a doubt. There are different types of cements available in the market. OPC, PPC, PSC and all those things. Normal doubt for all civil engineers which is best. And many times people are believing, or even the civil engineers are believing that OPC is best because we are using cement. In PPC, we are adding some fly ash. In PSC, we are adding some slag. These are the waste materials. But in reality, these mineral admixtures will make your concrete much better and durable. I will tell you how it is. So actually, this is the cement hydration reactions. We know the box compound C3S, C2, etc. If you forget it, don't worry. The cement will react with the water to produce calcium silicate hydrate and calcium hydroxide. In this, the calcium silicate hydrate will give you the binding property, whereas calcium hydroxide is crystalline and it will not give any binding property. Sometimes it will leach out. If your concrete is in contact with the water, you can see that some white patches on the surface. That is the leaching of the calcium hydroxide. When it leaches out, it will leave pores inside the concrete. Through that pores, all the detrimental components will go out. So when you are adding a mineral admixture, it is having reactive silica or alumina. This silica or alumina will react with this calcium hydroxide, which will not give you much binding property, and it will react with the calcium hydroxide to produce additional CSH, which is having binding property. So we will have more CSH so that more binding will take place, and this CSH will fill the pores of the concrete, and the concrete will be more dense and it will be more durable. So only the problem is when you are using pozzolanic material in concrete. So I am telling you the durability will be more because more CSH is there. So when you are adding the pozzolanic material, only one drawback is that first the calcium hydroxide has to form with the reaction of water with cement. Then that calcium hydroxide will be reacted with mineral admixture. So these reactions are little slow. But how much lag will be there, that depends upon which type of admixture you are using. If you are using a ricer's cash, it will take only 1 day. For silica fume, only 1 to 2 days. For class C fly ash, it's 3 to 7 days. For class F fly ash, 14 to 28 days. For slag, it is 3 to 7 days. These are taken from Taylor textbook. So don't tell that these if I'm not getting like that. These are values for an idea. It depends upon which grade of concrete you are using, how much percentage of fly ash you are using, what is the ambient conditions. All these are parameters for that. But one thing you can see that after 28 days, both will give you almost the same strength. And you can see from that graph, the ordinary Portland cement concrete, after 28 days, the strength will not go much beyond. Almost 90-95% strength will be achieved in 28 days. But the concrete with the mineral admixture will go on increasing in strength with the time. So for a long time, the strength will be much higher for blended cements than OPC. And the durability also will be higher. So always it is advantageous to go for blended cements. These things I'm just skipping these things as the time is limited. I think Manju, it's our time, right? Again, for sustainability, if you want, you can go for self-compacting concrete so that everything will be better. Then if you want, you can go for colored concrete, because if you want to repaint your concrete, that will take additional cost, time, raw materials, energy, everything. So when you are making your concrete, we can add pigments or oxide to the concrete. We can make the colored concrete. You can see beautiful colors in concrete. You can make any color. You can see a park bench with a red color with the pigments in concrete. So that is, again, if you are going for a steel structure, its embodied energy is too high. You need to repair it, you need to repaint it, all these things. If you make a colored concrete, keep it there and forget about it. If you want, we can make it with 100 years of life cycle. That's possible. Again, for durability, when you are going for the blended cements, you can see that the concrete without mineral admixture and with a fly ash PPC, you can say that in the compressive strength column, both are having almost the same compressive strength. Tensile strength and splitting tensile strength are a little higher. But look at the RCPT value and sorptivity value. The values are much reduced for the cements with a fly ash. That means the durability of the concrete is much higher with the blended cements, just like gravimetric loss and all those things. So with this, what I would like to show that a judicious use of admixtures can contribute significantly in making sustainable structures by reducing the raw material, reducing the consumption of the construction materials, by reducing the emission, by using the waste materials, industrial waste materials, otherwise it will go for the pollution issues, by reducing the cost. All this can be achieved and we can make a more durable concrete and sustainable concrete with the judicious use of admixtures, and the life cycle of the structure can be increased significantly. With this, I'm just winding up. If you have any queries, we can take some queries for some time.
Thank you, Dr. Elson John, for showering us with your pearls of wisdom and knowledge. The session was full of knowledge and interesting things. All of us came to know about the price of 1 kg concrete, about positive and negative impacts, then principles of concrete construction, correct use of admixtures, and all. Thank you. Thank you for making the session interactive. I hope all the participants have enjoyed it and benefited a lot. Now the forum is open for question answering session. Participants can unmute and ask your queries or may type your questions in the chat box. Sir, one question is, sir, what are the possible drawbacks of chemical retarders in structures?
What are they?
What are the possible drawbacks of chemical retarders in structures?
I couldn't find any negative influence of that, because whenever you are using, there's for a purpose. The application where we need long haul or hot weather concreting, all these things we are using. So we are using it for the advantage. Okay, but the problem is that if you are going for overdosing, you have to design your concrete accordingly. If you are overdosing it, your concrete may not set at all. I came across such issues where a building site where the concrete didn't set at all for 2 days. So the second day they contacted me. We went there and see that the concrete is not at set. So I asked them then I took the mixes in, I asked them what are the procedure. Then I asked them to wait for 2 more days before demolishing, and let us wait. If it gained the strength after 28 days, we can have a non-destructive as well as quarters from the sample and let us assess whether to demolish or not. But after 28 days, everything was perfect. Again, more than the disadvantages, there are one more advantage. If your concrete is set fast, slow, the initial heat of hydration also will be less. So that also is an additional advantage. Any other queries? Please feel free to ask.
Any other questions? Sir, one question is there in the chat box. What about ready-mix concrete?
I'm not fully aware, understood what is the question. Ready-mix concrete means it's a control mix. If you want to think, in my personal opinion, if you want to think about a quality concrete, you have to think about ready mix concrete or wave batching. Site mix, you won't get a good quality concrete because for a workable concrete without admixture in a site mix, you need minimum of water cement ratio of 0.6. Before that, you won't get a workable mix. And in IS code, IS 46 table number 5, for RCC, water cement ratio of more than 0.55 is not permitted. If you are asking me who is the enemy to concrete, I will tell the first enemy is water and the second enemy is cement. Because all the durability issues will take place only in the cement piece. Aggregates are inert material. All the whatever you are talking at, the sulfate attack, chloride attack, penetration or porosity, permeability, everything is happening. All the deteriorations are happening in the cement paste. So if you reduce the quantity of cement paste, durability of the structure will be reduced. So for a durable concrete, use as low water content and cement content as possible to get the required strength and workability. I'm underlining that word, to get the required strength and workability. So in that case, in ready mix plant, everything is controlled. So, and again in site mix, how they are weighing it, they are weighing with a pan, right? Some of the pans will be full, some of the pans will be partially filled. So in each mix, the quantity of material going will be different. That means, and cement content, they are just dumping one bag. So cement content is same, but aggregate contents and water contents are vary. So that itself can lead to different grades of concrete. Strength will vary. So in a structural element, if the different parts are having different strength or different permeability concrete, that itself will start forming the galvanic cell and corrosion of the reinforcement. But if you are going for a ready-mix concrete, everything is controlled. You can assure the quantity of material forms and the quality and uniformity of the mix. And the use of admixtures is also effective. So if you want a quality concrete, go for wave batching or ready-mix concrete. That's my personal opinion.
Thank you, sir. Any other questions? I think no more questions are there. I would like to remind the participants to fill the feedback form available in the chat box. Yes, Vasudev, sir.
I'm there. Elson, sir, thank you, sir. It was a nice session.
Thank you also.
I request Dr. Vasudev, our Associate Professor Takis, to give a feedback on the session.
Sure, it's my pleasure. Good afternoon, sirs, and good afternoon, teachers of the faculty members of MBITS Institute. And sir, today has thrown light towards the sustainability. That is, how can you acquire sustainability? Like what are the negative as well as positive features or the impacts while we handle concrete? Sir has clearly mentioned about it. And this is one of the important things that I have heard for the first time, that sir has gone how deep into the manufacture of the concrete. That means, sir, 1 kg of concrete, there was a remarkable thing I should remember forever, because it's very true, because I was just calculating it. I had 1 m³ of concrete bill was there. I was just searching for it. 2,400, if you divide, it is just coming to about 1.5 rupees. So as you said, it's very correct. So it is the cheapest one. Even one toffee, we have to pay 1 rupee, right? So with 1 kg concrete, we can at least repair one simple pothole. So we should understand in that level. So that is an eye-opener to all of us, I suppose. Manju ma'am, we have to make a note of it. It's a very important factor that sir has revealed today. And sir also has discussed about the adaptable principles that we are supposed to adopt for concrete construction. And sir reminded about the do's and don'ts of concrete manufacture, what all things we are supposed to keep in mind while we do sustainability, or we want to focus on sustainability while we handle with an ingredient which is not that sustainable. So it is our responsibility to make the concrete sustainable. And also sir has explained about that is his core area that I know very well, that sir will take around 1 day full class. He is ready to take that confidence I have, sir, in you, that you will be handling for mineral admixtures as well as chemical admixtures. So sir has thrown light onto it also. So thank you very much, sir. And I take this opportunity to personally thank my own guru, Dr. Elson John, for enlightening us and enlightening the entire participants of this fruitful FDP, which is we are marking sir is marking the end of this FDP, 3 days FDP, which was conducted by MBITS. And I once again thank all my respective teachers. Soli ma'am was there, and I tried to speak to ma'am, but I couldn't speak to her. So madam was there. So thank you very much once again to all MBITS family, as well as to give us an opportunity to attend this 3-day fruitful, sustainable developments that is happening in the construction sites. Even we are very much grateful to listen to almost all the speakers. Even though I was in the camp, I had an opportunity to listen all of it, and I was very much displayed, and I asked also madam to give me an opportunity to give the feedback for the first 2 sessions, which I couldn't do it. I'm very much particular about it, because wherever the concrete is there, if I find time, I will find time to get into that that FDP, because it's a new thing for every time. Because it's not that our Shaiju sir of Ambuja Cements used to say every time that making a concrete, it's or doing a mixed design is just like studying, and we have to practice it. It is as good as we are learning Kathakali. We are supposed to treat it like that. So we have to practice, then only that entire mudras will come into our hands, and we can make it so beautiful. So I think the same way all our participants will be benefited from the entire lecturers of this series. And I think sir has enlightened us with the core of manufacture of concrete using the sustainable norms. Thank you very much for your kind listening, as well as thank you very much to my own guru, Elson sir. Thank you very much.
Thank you. Thank you, Vasudev.
Thank you, sir. Once again, thank you all for the active participation, and thank you, Dr. Elson John. Now it's time for valedictory function. On behalf of MBITS, we are delighted to offer a gracious welcome to all of you. It gives me an immense privilege to invite Dr. Sojan Lal, beloved principal, to address the guests and the participants. Sir. Sir? Sir, are you there, sir?
I think sir didn't join. I think you can call sir. Gidu?
Sorry, ma'am. Namaste.
Hi, namaste, Vasudev. I was watching you.
Thank you very much, ma'am. We were also trying to contact you the first day.
Convey regards from sir also.
Thank you very much, sir. Thank you.
Vasudev is here. Actually, we are out of station.
Yeah, came to know you were speaking about it.
Yeah. Hope you all are benefited by the FDP now, Vasudev.
Extremely, ma'am, because so many expert knowledge was delivered during the session. And
Yeah.
thanks to the lockdown, so that we were all listening to it.
Yeah, that is true only.
Yeah, we are having IATS also here, so classes also was not that much. So we could manage to listen to all the lectures.
Yeah.
Now principal has joined. I invite Dr. Sojan, the level principal, to address the guest and the participants.
Good evening to all of you.
Good evening, sir.
Good evening, good evening. And I'm really happy that 3-day session was very fruitful, as well as some of the sessions I also attended, and I've noticed that there is a lot of learning points are also there. So first of all, I was just thinking that what we will do after this course, because a lot of learning points are there, and how we'll be able to see the outcome of this. So one suggestion is that maybe after 6 months, we will evaluate what a teacher has done or what as an institute has done. So maybe we can think of a best teacher award and a best institute award. So I take your opinion, maybe in the chat box. So what is your suggestion into this? So the eligibility is already who are attended this program. So that is what we are primarily focusing on. So what is your opinion? You can also type in the chat box. The second thing is that I understand that there is a, what do you call this, quiz program was conducted. And I would like to announce the name of the faculty members. Miss Anjali Baby, Assistant Professor of Department of Civil Engineering, IES College of Engineering, Chittilappilly, Thrissur. Congratulations to the winner, and scoring 17 points out of 20. Congratulations to all the participants who are participating. And also, I also noticed that there are lots of faculty members are having the real practicing experience. That's really a very good point about this. So maybe one of you can make a comment on the remarks which I made regarding the best teacher award and the best institute award, based on the outcomes which you may come across within the next 6 months of time. So it's really a very great pleasure to know that MBITS from all the departments and various IQAC and other departments and forums are bringing such a impressive programs, and also all the faculty members, practicing engineers are all joined over here. And last year we could conduct as many number of programs, and more than 12,000 participants, as I mentioned on the first day, was attended. So subsequently, we will also continue our efforts in doing this. Thank you very much. And Manju and all the team members have done an exceptional work for coordinating this and bringing the faculty and all. Dr. Solly George, your participation and coordination was excellent and motivating this. And once again, thank you all and have a nice time. Over to you. Thank you.
Thank you, sir. Congrats, Ms. Anjali Baby, Assistant Professor, IES College of Engineering, Thrissur. Congratulations for your achievement and getting the prize money. I request any other participants to give a feedback.
Yes, ma'am.
Yes, sir. Rajkumar, sir.
Yes. Yes. Good evening to everyone.
Good evening, sir.
Especially thanks to our institution director and principal sir and HOD and the faculty members, my dear participants and everyone. Good evening. Surely your very achievement and remarkable 3 days we have to learn, and every one session it will be interesting one. It's not only boring. FDP always they are think about for boring. For every one session, your research oriented, there will be arranged that session for every one speaker. Your industrial and research academic oriented person, there will be collaboration. For we have to achieve the learning. And also already told our principals are your last 6 months will be improve our any kind of research work, any kind of work, sir. Sure, definitely your speech that we have to implement our faculty members, sir. Sure. Thank you, ma'am, and especially once again thank you to our sponsor team for APJ Abdul Kalam Technical University. Thank you. We have to learn in everything, very useful, and we have to attend the faculty members in our department. Faculty members, all the faculties, we are attending the FDP every one day. We are learning and very remarkable, ma'am. Sure. Thank you. Thank you once again. I would like to thank.
Thank you, sir.
Thank you,
Now
ma'am.
I invite Dr. Elson John, Associate Professor MACE, to share a few words with us.
Respected Principal, Dr. Sojan sir, dear Solimis, Manju, head of the department, and all the faculties over here. I think I don't want to make you bore more because you are bearing me for last 1.5 hours. Anyway, I congratulate actually the Department of Civil Engineering and MBITS College, because especially MBITS is doing a lot of programs and coming up with lots of innovative ideas. Even today, sir was talking about an award. So Sojan Lal sir is always like that. From the day onwards, he became the principal. The MBITS is doing a great job in these areas, especially the extracurricular areas. And of course, about Solimis, if she is there on the top, certainly civil engineering department can do wonders, because always I know Manju will get benefited out of it, because I'm personally, I got a lot of help and motivation from Solimis and Matthew sir. Even in my development of in my career, as a long time we were together as a colleague. Before that, she was my professor. So I know how she will nurture the department and the young faculties. So thank you, Solimis, for that. And for all the faculties. So what I just want to tell one thing. So one of the major problem what we are facing in our academic curriculum is, after getting out, the civil engineering students, there is a major complaint that they don't know anything practical or field oriented or anything. So in one way, I want to ask one question to the teaching fraternity over here. How many of the teachers are having that? We are learning something from the textbook and giving to the students. Can we give anything extra? Even my area and my passion is concrete technology. So even all the structural engineering or civil engineering are designing the concrete structures. But before doing that, are you aware? Are you expert? Are you aware about the problems in that? Because in KTU, it is still pathetic. It is very sad to say that wherever you go, whichever field you go in civil engineering, you have to deal with concrete. But concrete technology is not at a core subject. We are offering 2 or 3 electives, and only 1/3 or half of the students are learning concrete technology. And others, they don't know anything about it. And they are going to the field and they are dealing with it. So whenever we are getting an opportunity, we have to give them little extra. When I am telling this, you may be laughing and thinking that extra. But if we decide, they will be interested. Give them the assignments, give them the work, explore them. Our kids are too smart. Our kids are too smart, even smarter than us. So we have to get. And when I told you so far about sustainability and concrete technology, the problem is that here all the civil engineers and structural engineers are designing the concrete without knowing anything about it. Getting an MTech in structural engineering is not the qualification to design a concrete. At least he should learn it. So many times that we are doing the things without we are doing it. Was rightly taught. We have to do it with our hands. We have to experience it. We have to understand it. Without that paper knowledge, so we also have to explore. So to all the teachers, what I would like to do that, do as much work in the field as in the form of consultancy or training, or whenever you get a site, visit the site or do something, get exposure out of it. That will be benefited to our students to a great extent. With this, I'm just winding up. Once again, thank you for MBITS for giving an opportunity to interact with you, share what I know with you. Thank you. Thank you all.
Thank you, Dr. Elson. That we are very glad that practicing engineers like you, many people are also in the form. Really great, Dr. Elson.
Thank you. Thank you, sir.
Thank you, sir. I invite Dr. Solly George, Dean Planning and Development, MBITS, to share a few words.
Thank you, Gidu. Am I audible?
Yes, ma'am.
Okay, thank you. Good evening to you all. Chief guest or
Good evening, ma'am.
pardon? Am I audible?
Yes, ma'am. Continue.
Okay. President of the function and beloved principal of MBITS, Dr. P. Sojan Lal, and the concluding resource person of the FDP and guest of this valedictory function, my student, my colleague, earlier colleague, Dr. Elson John, and all the participants of this 3 days FDP, which is sponsored by KTU on the sustainable building materials and practices. And my dear colleagues, I hope the coordinators and the department deserve a big round of applause as they could conduct this FDP to their level best by bringing the most eminent resource persons in this area of sustainable building materials, and that too the appropriate topics justifying the title of the FDP. In addition to this, we could get an awareness about the sustainable water management, which is also very relevant. In this area, our government is putting maximum effort to keep our water bodies clean, and that too by bringing the involvement of students and teachers by doing projects. And here, my request to the participants is that not to simply attend the FDP, but we should do or give some innovative projects in this area. Then only the purpose of this FDP is served. Hope all of you will take some initiative. I also take this opportunity to congratulate the participants for your active involvement by interacting with the resource persons and asking relevant questions so that other participants could also be benefited. Once again, I congratulate all the participants. I also thank all the resource persons who took all the sessions in an interesting and efficient way. Once again, I congratulate the principal who is giving all moral support to all the departments for coordinating all these type of webinars and FDP. I'm not extending much. Once again, I wish all good luck to all the participants and congratulations to the coordinators and the whole department for this FDP with relevant topics, and that too in this COVID peak scenario. So I am telling all of you to be safe at home, and I think in the next week also the peak will be high. So stay safe at home. Thank you all once again. Wish you good luck.
Ma'am.
Thank you.
I invite Assistant Professor Manju George, HOD, Civil Engineering Department, MBITS, to deliver vote of thanks.
Thank you, Ms. Gitu. Respected Principal, Dr. P. Sojan Lal, Professor Dr. Solly George, our resource person, Dr. Elson John, dear participants, and my dear colleagues. A very good afternoon to one and all. First of all, let us thank the God Almighty for keeping us much safe, for conducting such an event which share abundant knowledge in the area of sustainable building construction, even during this COVID-19 crisis. It's a proud moment for the Department of Civil Engineering of MBITS that we could organize a 3-day faculty development program on sustainable building materials and practices through a digital platform. With much pride, I thank APJ Abdul Kalam Technological University for sponsoring the program, who consistently support these kind of programs very much. For the past 3 days, we had 9 sessions by eminent resource persons who expertise in the area of sustainable building construction. On the first day, we had Dr. N.V. Ramana Rao, the Honorable Director of NIT Warangal, who inaugurated the program, followed by his keynote address. He is willing to associate with our institute in most of the programs we are organizing. On behalf of the Civil Engineering Department of MBITS, let me thank Dr. N.V. Ramana Rao for his kind association. Also, we had Dr. G.A. Eldo, Professor, IIT Bombay, Dr. Prakash Nandagopalan, Associate Professor, IIT Bombay, Dr. B.B. Das, Associate Professor of NITK Surathkal, Dr. T. Palanisamy, Assistant Professor of NITK Surathkal, and his research scholar, Dr. Ajmal Muhammad, Dr. Anil Joseph, Managing Director of Geostructurals Private Limited, Engineer Shankar N. Menon, Director of Seed Engineering Consultants and Academy, Dr. Job Thomas, Professor of CUSAC, and for the last session, Dr. Elson John, Associate Professor of MACE, as our resource persons of various sessions. On behalf of all the Department of Civil Engineering, MBITS, and all the participants who wholehearted thanks to all of them for accepting our request and sharing their valuable knowledge to all of us. The success of this program is due to nothing but the active participation of all our dear participants who eagerly interacted with the resource persons and made this program very fruitful. On behalf of the Civil Engineering Department of MBITS, let me thank all our participants for making this FDP a grand success. I wish all of you and your students will be benefited by this program. Let me thank our beloved principal, Dr. P. Sojan Lal, for being the pillar of support for all the works behind that program. Thank you so much, sir, for all your guidance and remarkable contributions. Professor Dr. Solly George is a constant motivator for us, and I thank Dr. Solly for her support for the coordination of the program. Thank you, MBITS management, for letting us to organize such a program and all their support. Finally, congratulations to my co-coordinator, Ms. Deepthi Worki, and all my dear colleagues for contributing to organize such a program in such a well-coordinated manner. Thank you all for your exceptional support. Once again, thank you all for making this program a grand success. Stay safe. Thank you.
Thank you, ma'am. Now I request all the participants to switch on your video to take a screenshot. Please switch on your video for 1 minute. Only some participants shared their video. Others, please. So it's only for taking a screenshot of our program. Thank you. The end of a story is the new beginning for many others. On this note, let's conclude a remarkable, memorable, and knowledgeable FDP. On behalf of MBITS, we sincerely thank all the participants and speakers for being with us and enlightening us with their enthusiastic remarks. I would like to take this opportunity to express our hearty thanks to Assistant Professor Manju George, HOD CE Civil Engineering Department, for the perfect logistic support and guidance she has extended to all of us during this FDP. I shower my heartfelt gratitude to our principal, Dr. Sojan, Dr. Soli George, all my colleagues and everyone of MBITS family for their wholehearted support rendered in the success of this program. Thank you very much. Have a wonderful and fun-filled evening. Thank you.
Thank you all. Have a best time. Bye-bye.
Thank you all once again.
Thank you.
Thank you, ma'am. Thank you.
Thank you, ma'am. Thank you so much.
Thank you, sir.
Ma'am, session will be finished. Leave it. We can,
Yes, sir. Yes, sir. You may please.
we can leave it.
Thank you. Thank you
Okay.
so much,
Thank you.
sir,
Thank
for your active participation. Thank you so much.
Yes, ma'am. Really appreciate for in this occasion. I would like to thank for yourself, ma'am, for the arrangement of FDP. Then only we are get the learning and the knowledge we will be celebrating, ma'am. Really, you are. I would like to thank for yourself, ma'am.
Thank you so much.
Thank you.
Accepting
Thank you so much,
more association with you, sir.
Yes, definitely, ma'am. In future, we will for conducting the lot of program. We will be sharing and we will inviting in our college, ma'am. Definitely, we will participate and we will get the support, ma'am.
Thank you, sir.
Okay.
Sure, sir.
Thank
Sure.
you, ma'am. Thank you so much. Thank you. I will leave it, ma'am.
Yes.
Thank you.
Hmm.